Hello students, in the last class we have discussed about the block diagrams, operational amplifier definitions and how the pin configuration it is, how it is working. We have already explained all those things. In this session I am going to explain about the characteristics of operational amplifiers and how it behaves, input and output characteristics, and the ideal and the practical operational amplifier characteristics. Yes, let us start these sessions. Right, let us start these sessions. We are going to explain about the um, ideal characteristics of an op amp. First one is a infinite gain. The gain is infinity. Infinity means it is too high, right? The definition of the infinite means infinity means it is a high. The voltage gain, the gain means what? V naught by V in, we have already studied. Output voltage by input voltage, we can call it as a gain. Like in the operational amplifier, I want to draw it and explain it. Yes, I'm going to take it this one is a operational amplifier. It is a high, the infinity, the gain is infinity we are giving. This is the 741 IC operational amplifiers. The difference between this one is positive and negative, inverting and the non-inverting terminal. This one is a V1 and this one is a V2. These are the two voltages are there, V1 minus V2 or V2 minus V1. We have to take it, and the V0 equals to A into VID. VID we can take it. VID means the difference between the input voltages, right? That the voltage difference at the two inputs is magnified. It is a infinity. This is a infinity, it is there. Infinity it is there. Like, and the difference between the two inverting and the non-inverting terminal is amplified by 2,50,000. It is the gain, it is there. It is the actual at present. We can take it as a practically it is 2,50,000 we have calculated, but the operational amplifier who have um, invented on that one, they are telling like that it is a infinite voltage gain, we can telling, we are telling like that. Like the voltage gain is infinity. Why? Because it is the difference between the two input and the inverting and the non-inverting terminal into the gain. We can use it using like that. It is a infinite. As a practical, it is a 2,50,000 and it is a approximation value, not it is a confirmed value. The infinite input resistance, so that the almost any signal source can be effect of the preceding stage. Infinite input impedance. Now I am telling about the Ohm's law. If the resistance value is more, if the resistance value is more, the current will be the less. Is it correct? The resistance value will be the high, the current is low. The infinite input resistance, the same way I am going to take that. I'm going to take that one, right? And I'm going to take that one. This one is inverting terminal, this resistance is infinity. This resistance is infinity if the input impedance or a input resistance is infinity. The obviously the current will be the zero. The current will be the zero. It is a zero current, it is there. Why? Because by Ohm's law, in truth, about the 10 raised to 12 ohms for the FET input op amp. What is that one? It is a approximately it is 10 raised to 12 ohm for the truth value for that one. Infinite input resistance, the current will be the almost zero. And next is a zero output resistance. Zero output resistance, the current will be the more in the output. The resistance value is zero, the current is maximum. The zero output resistance, so that the output can be drive an infinite number of other devices. What will be the infinite? Current will be the more, the obviously the voltage will be the high. Voltage will be the high, right? And zero output voltage when the input voltage is zero. Yes, input voltage with for example it is a zero. I'm going to draw like that. For example, I'm going to take that V A equals to V naught equals to A into VID. If the VID is 0, the output voltage will be the 0. It is a normal configuration for the operational amplifiers. The input voltage is 0, the output voltage will be also 0, right? 0 output. Infinite bandwidth, so that any frequency signal from 0 to infinity hertz can be amplified without attenuation. Practically the limited in mega ohms it is there. The bandwidth of the operational amplifier, it is very high. Very high means it reaches to the infinite hertz. Infinite common mode rejection ratio, so that the output common mode noise voltage is 0. In the further parameters of the operational amplifier, I am going to explain about the what do you mean by the CMRR. We can call it as a common mode rejection ratio. Now you can study about the just basic of the CMRR. In the further classes, I am going to explain about the whole definitions and all those things about the CMRR. The infinite common mode rejection ratio, so that the output common mode noise voltage is 0. Infinite slew rate, so that the output voltage changes occur simultaneously with the input voltage changes. Thus infinite slew rate, why? Because the input voltage, how it is changes, the output voltage also changes, because the V naught equals to VID. It is the difference between the inverting and the non-inverting terminal. If the whether the whatever changes in the two inputs, we can get the it affects on the output, right? And the same way, same changes it is there. We have studied the ideal characteristics. First one is a infinite voltage gain and the infinite resistance, input resistance, otherwise input impedance, we can call it as zero output impedance. Zero output impedance means the output voltage and the current will be the more, and the zero output when the input voltage is zero. Infinite bandwidth. Bandwidth means the difference between the higher frequency and the lower frequency. It is called it as a bandwidth. The higher frequency will be the more, the lower frequency will be the less. For example, you got the 1 megahertz of the frequency fh. Fl is 10 hertz. It is nearly equals to the fh, that is the higher bandwidth. The bandwidth definition is the difference between the higher frequency and the lower frequency. Infinite bandwidth, infinite common mode rejection ratio. The output of the common noise voltage is 0. The infinite slew rate, if it is there, the output voltage changes occur simultaneously with the input voltage changes. Right? Next, the practical characteristics of the operational amplifier. The open loop gain practical op amp is around 7000. It is there. Open loop gain, it is the in your open loop and the closed loop configuration, it is there. In the further classes you can study it. Before going to the characteristics, I am going to explain. Practically it is around the 7000. It is there. Practical op amp has non-zero offset voltage. This is the zero output is obtained for the non-zero differential input voltage only. Right? The practical op amp has non-zero. The practical is the operational amplifier is a offset voltage. The offset voltage, we can parameters, we have to study about the offset voltages. What do you mean by offset voltage? This is the zero output is obtained for the non-zero differential input voltage only. If the non-zero input voltage, we can obviously get the non-zero output. Correct? The way of they are telling like that. The bandwidth of practical operational amplifier is very small value. This can be increased to desired value by applying the adequate negative feedback to the operational amplifiers. You have already studied in your amplifiers in the previous semester, positive, and in the transistor biasing you have studied about the negative and the positive feedback. Here applying for the negative feedback, and they can ask the questions for 5 marks. What is the need of the negative feedback for the operational amplifiers? Why? 2 marks they can ask for that. 5 marks they can ask for the some derivation. It is the negative feedback. In the further classes I will explain the negative feedback. What is the need of that one? They can ask for 2 marks. You can give the answer. Bandwidth of the practical is very low. That's why we have to get the more bandwidth. That's why high frequency we can get that. Bandwidth means FH minus FL. I told that FH will be the high, the FL will be the less. Then only we can get the higher bandwidth. That is the need of that one. We can do the negative feedback to the operational amplifiers. Right? The op amp output impedance is in the order of hundreds. This can be minimized by applying an adequate negative feedback to the op amp. One more advantage of the negative feedback, that's why I asked you about this 5 marks also they can ask for that one. The output impedance hundreds you can get that one. Obviously the current will be the more and the voltage will be the more. 100 it is there, we can get the, for example, you can minimize it hundreds to 0 andra. For example, your output impedance is 1000. Obviously the current and the voltage will be the very less, right? If you want to minimize to the zero resistance, the current and the voltage is nearly equal to the input. Whatever we are giving the input, we can get the output, right? That is the importance to the negative feedback. The input impedance is in the order to mega ohms. Input impedance is high, the obviously the current will be the less. Where is the ideal operational amplifier has infinite impedance? We can tell it like that. The ideal and the practical characteristics of op-amp. This is very important for your examinations, and they may ask for the difference also. Difference they may ask for that one, right? Keep it in your mind. uh, these are the very important for that. Open loop gain of the practical operational amplifier, it is 7000. Practical non-zero offset voltage, this is the zero output obtained for the non-zero differential input voltage only. The bandwidth of the practical is very low. We can do the negative feedback to the operational amplifier, we can get the high bandwidth, and the output impedance is around in the hundreds, we can minimize it. Why? Because to the high current and the voltage, applying the negative feedback, we can minimize the resistance value. The input impedance is in order to in the megahertz. Obviously in the ideal characteristics of an op amp, it is very high, that's why they have mentioned in the megahertz. Now we are going to study about the difference between the ideal and the practical operational amplifiers. Alright, the voltage gain is ideal is infinite, practical is high. We can mention it as the value of that one is 10 raised to 5 to 10 raised to 9 volt. It is there, not volt, it is a gain. Gain means V naught by V in, it is there. The difference between the ideal and the practical operational amplifiers. The input resistance, is high, otherwise input impedance is high. The high means it is in the megahertz. They have already told that in the practical operational amplifier we have explained about that. uh, you can tell that input impedance is in the order to megahertz, they have told that. That is the value they have mentioned here is 10 raised to 6 to 10 raised to 12. Start from the megahertz. Yes. Output resistance is 0. Output resistance, we can do that one to the negative feedback, we can apply it, then only we can minimize the output resistance. 0, that is low. 100 to thousands, it is a 100 to thousands, it is there, we can minimize it in the ideally we can tell it it is a 0, but we can't practically do that one, but we are trying to do that one by the negative feedback method. Output voltage when input voltage is 0, it is a 0 volt. I told that input voltage is 0, obviously the output voltage also a 0. It is the practically we can tell it as a low, but we can't tell it as a 0. We can at least microvolt or a millivolt we can tell that. Bandwidth is infinite, the practically it is a very less, but we are trying to express that one by using the negative feedback, we can increase the bandwidth of the operational amplifiers by using this method. by the negative feedback method, right? Bandwidth infinite, we can tell it as a ideally. By tell it as a practical operational amplifier, it is high 1 to 200 megahertz, 1 megahertz to 200 megahertz, it is a too high, right? CMRR, it is a common mode rejection ratio, we can tell it. It is a infinite, it is practically, it is a very high. And the sleeve rate, it is a infinite, it is too high for the practical operational amplifiers. For your examination, they can ask for the ideal characteristics of an op amp, otherwise practical characteristics of an op amp, and the difference between the ideal and the practical operational amplifiers. Yes, right. We have discussed about the practical and ideal op-amp differences. This is very important for your examinations, and ideal and the practical operational amplifiers also. Now we have discussed about the next is input and the output characteristics of the operational amplifier. We have to see this one. This is the characteristics graph of the operational amplifiers. Yes, this one is about the maximum output of an operational amplifier, it is limited, right? And by DC power supply, we are using the power supply, it is in the DC power supply. And DC power supply, it is we are using the operational amplifier, both AC and the DC we have to use. In the DC power supply we are using for that one, most output voltage executions are limited within plus VCC and the minus VEE, where the similarly the output current from the operational amplifiers are also limited. The saturation voltage below is an example of the operational amplifiers with the gain is 1,28,576, it is there, right? That is the gain, it is there. And the power supply voltage is equal to the plus 9 volt, it is there. The input voltage exceeds plus or minus 70 micro volts. Operational amplifier starts exhibits the non-linear characteristics of operational amplifier voltage saturated at plus or 9 volt, it is there. The characteristics we have seen in this, it is the voltages increases with the current, we can see that one. uh, that is the input characteristics. Here we can see that one, it is in the saturation, it is call it as a positive saturation, and it is call it as a negative saturation. For that one, we can see that one, negative saturation and the positive saturation. The range of that one is a plus is a positive, it is the plus 70, and the minus 70 millivolt, it is there. The 9 volt, it is the power supply of that one in the saturation regions. And open loop configuration, we can see that one. And input and the output configurations in the practical op amp, uh, the voltage is around the plus 9 volt and the minus 9 volt. We can see in your practicals also we can DC power supply, regulated power supply we have used. For the middle one we can connect it for the ground, we can see that one is plus VCC and the minus VE. And this is a saturation region for the positive saturation, and this one is a negative saturation, we have to see that one. This is the input and the output characteristics of the operational amplifiers, and the balanced and the imbalanced power supply. We can see that one. We are going to study about this one is for example, I'm going to draw it here. I'm going to draw it here. This one is a power supply, this one, and this one we are going to connect it. This one is connected to ground. This is 12 volt. This is also a 12 volt. We can call it as a balanced power supply, and I'm going to draw the same circuit is here and here. It is a ground, and this is also a ground. That is also a ground. This is a 12 volt, and I'm going to take it as a, this one is a 15 volt power supply. I'm going to take it. This is called it as a unbalanced power supply. I'm going to tell that one. This is a we can see that one. This is the balanced and the unbalanced of an op-amp. We can see it by the power supplies. For example, VCC. Plus VCC is a plus VCC. I am going to draw it here. This one is a operational amplifier, plus and minus. This is plus VCC minus VE. I am going to take it. This is for 12 volt. I am going to take it for the 9 volt for the negative supply. If another supply I am going to take it is in this circuit, we can call it as a imbalanced power supply. We can see that one, right? The power supply, it is the how we can take that balanced and the unbalanced power supply. At the same way, we can see that one in the single ended and the double ended circuit. We can see that one. Single ended means we can see the this one is a first circuit. If you are inverting terminal, it is there, otherwise non-inverting. Here inverting circuit, this one is a non-inverting circuit. We are going to single ended means the power supply is connected to the non-inverting terminal. The power supply is connected to the non-inverting terminal, right? The power supply is connected to the non-inverting terminal. We can get the this kind of output. If the power supply is connected to the inverting terminal, the phase, the angle will be the 180 shift. It is there. We can get the these kinds of output, right? And this is called it as a single ended input, and the output we can call it as. In the double ended, we can see like that. Double ended, we can join the both the supply ACs. Inverting and the non-inverting terminal we have joined separately. We can join separately, and the signal it is there. We can get the, if you are joined, or we can connect the both the inputs, but we can, whatever we are giving the voltage here, the both the voltage are the same value. We have to take that one. We can get the output in the same, right? Then it is a double ended output. Double ended output, we can see that one. We are connecting to the non-inverting terminal, otherwise we can join it here. This one is a circuit for that one. This one is a circuit here. We can connect it to the double-ended circuit. We can join it here. It is in the we can see that one, right? V1 and the V2 we have connected. This one is a V1 and V2, and V1 and V2 two output. We have to see that one. And here also the V1 and the V2 are the invert and non-inverting. We have to see that one. If you are wherever you are connecting the circuits, you can get the output like that. We have to see the both the connections. We have to see that one. This is the double-ended output circuit. This is also very important for single-ended and the double-ended. For your practicals, it is very useful for that one. Why? Because of the how we are connecting the circuits. The power supply, it is the very important. In they can ask these questions for the practical examinations. They may ask for that one, single-ended and double-ended input output. They can ask for that one. That is also a very knowing thing to understand the concept. Okay, in the next session I'm going to explain about the parameters of the operational amplifier. That is also very important for you to understand the topic of the operational amplifiers. Okay. Next session we have to meet it, and we have to watch the videos regularly.